Hello. Here we are going to see how to factor quadratics and thus find their roots. Roots are just values for x that make the expression 0. We then list out all the roots as solutions to the equation. So guys, let's go over an example. In our first example, we're solving the equation x squared plus 5x plus 6 equals 0. And we have to understand that this entire thing right here is called our quadratic. The term with the 5x right here is the term with the x, and the 6 is our constant. And the key to understand a quadratic is that it's the product of two linear terms, which is to say that this whole thing can be expressed as x plus b times x plus c, where b and c are both constants. Now, the difficulty is that we don't know what b and c are, and in order to solve for the values of x, we're going to solve for what b and c are. So we're going to multiply this x plus b times x plus c, which we see as x squared plus cx plus bx plus bc, which simplifies to x squared plus, in parentheses, c plus b, times x plus b times c. So thus, we are looking for two numbers b and c, which add to the term x and multiply to the term that has the constant involved. So we're going to consider all the factors of the constant term, which in this case are 1, 2, 3, and 6, and also their negative versions to solve for b and c. And if we examine the constant term, we're going to find that when b equals 2 and c equals 3, we get x plus 2 times x plus 3 right over here. And that right there is going to multiply out to x squared plus 5x plus 6. And now you might be wondering, well, how does that give us the answer? And the trick is that when either of these two things equals 0, because 0 times anything equals 0, the whole thing equals 0. So now x plus 2 equals 0 and x plus 3 equals 0, so when you move it to the other side, you get that x equals negative 2 and x equals negative 3. And these are both solutions because if you plug them into the original equation, you can see that the equation is true. So if we plug in x equals negative 2 into the original equation, we get 4 minus 10 plus 6 equals 0, which equals 10 minus 10, which is obviously equal to 0. And if we are to plug in negative 3 into the original equation, we get 9 minus 15 plus 6 equals 0, which is obviously true. So now that's how we solve these problems, and let's get on to our practice. So here are 4 practice problems, and I encourage you to pause the video and try your best to solve these problems for x on your own, and then we're going to go over them in our key below. 5, 4, 3, 2, 1, done. Okay, let's go over our key. So, our first question asks x squared minus 4x plus 4 equals 0. So we're going to consider the factors of 4. Now, it turns out that when b is negative 2 and c is negative 2, and yes, they can be the same, we get x minus 2 times x minus 2, which does in fact match our original. Hence, x equals 2, and we can verify by plugging in that when x is 2, we get 4 minus 8 plus 4, which is in fact equal to 0. Now, for problem number 2, we're going to consider our factors of negative 10. We want two things that add to 3. So, we have b is 5, c is negative 2, and you see that 5 like minus 2 is 3, so it adds to 3. So x plus 5 times x minus 2, sure enough, expands out to x squared minus 2x plus 5x minus 10, which is equal to x squared plus 3x minus 10, which is correct. Now we're going to briefly verify them, and you can see some simple verifications that they're correct. Now we're going to do the third example problem, where we have x squared minus 11x plus 24 equals 0. And we consider the factors of negative 24, but none of them seem to work right away. But what if we use the negative versions? Well, when b equals negative 3 and c equals negative 8, we get x minus 3 times x minus 8, which expands out to x squared minus 11x plus 24, which is our original. And thus, when we move the negative 3 and negative 8 to the other side, we get that x equals 3 and 8. And we can verify them here, as you can see. And then we're going to go on to the very last one. Now, this one right here is a bit trickier because this one right here is what we call a difference of squares. Why? Because it has no middle term. So we have to find two terms that add to 0 but multiply to negative 49. So we're going to say that b equals negative c and b times c equals negative 49. So some simple algebra gives that negative b squared equals negative 49, and thus that b squared equals 49. So logically, b can be either plus 7 or minus 7 because 7 is the square root of 49. And C is the opposite. So one of them is x plus 7, one of them is x minus 7. So therefore, our solutions are going to be negative 7 and 7. Thank you all for watching, and good luck with quadratics.